South America, 15 million years ago. A monster creature called the terror bird is the king of beasts in this terrain.
You look at them, they have this absolutely huge head. This would have been a very powerful weapon.
For the only time in history, a bird is top predator on an entire continent. Then, the terror bird treks 7,000 miles to North America. Here, fierce wolves and saber-toothed cats rule the land. And the giant bird has a fight on its hands. In this epic conflict, who would prevail? The birds from the south or the beasts of the north? In the chronicle of life on Earth, dinosaurs reigned as history's greatest predators. They ruled the planet for 150 million years, but came to a sudden end 65 million years ago. Many believe an asteroid or comet killed off the dinosaurs. Once they were gone, the job of top predator was open. Mammals would become great predators on the rest of the planet. But in South America, things were different. The Isthmus of Panama had not yet appeared, and waters surrounded the continent. In this isolation, evolution took a strangely different turn. The continent was a giant island, laced with open savannas bordered by forests. Here, the mammals were docile plant eaters, ranging from large sloths to bizarre armored creatures such as the glyptodont. In this setting, the role of top predator went to a family of freakishly monstrous birds. Today, we call them the terror birds, and they ruled for 58 million years.
If you look at the head, is enormous, like in all terror birds, and the bird would have been able to strike with enormous force, and such a force that by hitting a prey, it would have possibly killed the prey almost instantly.
How could birds have attained such power? Evidence of the true nature of these enigmatic beasts is found first in fossil beds and later in scientific laboratories. But the terror bird family remains largely a mystery. The fossil record reluctantly giving up clues in an ongoing investigation that began more than 120 years ago. The year was 1887. Paleontologist Florentino Ameghino wrote of a fossil unearthed in Argentina's Patagonia region. It was part of a strange toothless jawbone from a skull that would have been 2 feet long. So big, thought Ameghino, it must belong to a mammal.
Then in time, with more discoveries and more studies, he realized that he had made a mistake.
It took scientists another 4 years to identify the big predators as birds. The key clues were in the center of the fossil bones themselves. Dr. Luis Chiappi is one of the world's foremost experts on these creatures. He studies terror birds at the Natural History Museum in Los Angeles.
Sometimes it's not easy to tell apart a bird bone from one that is either of a mammal or another reptile. But one thing that in general is quite consistent is that bird bones are hollowed and they have very thin walls, as opposed to the bones of reptiles or mammals that are not. Here on my right hand, I have the bone of a crocodile, and you can see the difference.
In time, a scattering of other fossils was discovered. Birds, yes, But what kind? They were undoubtedly big and certainly flightless. And then, skulls with sharp hooked beaks turned up, meaning these were monster carnivores.
When they finally found a complete skull of a terror bird, they knew then that it was not a toothless mammal, but that in fact it was a predatory bird, and a gigantic predatory bird.
Hooked beaks and sharp talons are two characteristics terror birds share with all modern raptors. But scale it up to the size of a 6-foot, 400-pound bird, and the result is frightening. In the 100 years after the first discovery, scientists collected enough fossils to identify 17 different species of terror birds. They varied widely in size and lived at different times during a period nearly 60 million years long. But in 2005, the unexpected happened. What appeared to be a totally new terror bird came to light in Argentina. High school student Guillermo Aguirre-Zabala was fossil hunting with a friend when they stumbled onto an historic discovery. Guillermo, now a paleontology student in Buenos Aires, had been interested in fossils ever since he was a young boy.
El hallazgo fue
The find was in the summer of 1999. I don't remember the exact date, but it had to be March.
tiene que ser marzo.
It all happened outside the village of Camacho, near the western edge of Argentina's vast region of Patagonia. Terror birds are known to have ranged from here through Uruguay and Brazil.
Nosotros ya habíamos encontrado algún que otro fósil, unas mandíbulas.
We had already found some other fossils, so we knew where to look and how to recognize fossils.
De conocer los fósiles. Este particularmente estaba.
This one in particular was almost completely covered.
cubierto.
When we found the first pieces, we made contact with the Paleontology Museum in Bariloche.
Nos contactamos con la gente.
That's where we learned how to dig around the fossil and extract it.
Y bueno, ahí es donde aprendimos a extraer fósiles.
Guillermo and his friend carefully covered their find and took it 40 miles away to the town of Bariloche. They gave it to the town's tiny paleontology museum, where it remained nearly unnoticed for 5 years. When Luis Chiappe learned of the find, he led an international team to determine the new specimen's place in the family of terror birds. He discovered it was a totally new species.
Seeing this enormous skull that's about 20, almost 30 inches in length is just like, psh. I mean, it's a wow moment, no question about that.
Chiappe's team dated the skull at 15 million years old and named it Colenkin Guillermoy. Colenkin for a native Patagonian spirit, Guillermoy for Guillermo. Colenkin was a spectacular find. It was a new species with a head unlike any other bird in history.
At 28 inches long and with a skull essentially bigger than that of a horse, the skull of Colenkin is the largest bird skull ever.
Chiappe compared other terror bird fossils to Colenkin's skull, plus a leg and toe bone found with it. He hoped to learn how big Colenkin was, how strong, how fast.
I'd like to, see whether we can talk to Sarah.
By examining the skull from a smaller terror bird, Luis Chiappe begins to get an idea of what the new species looked like. While in Bariloche, paleontologist Sarah Bertelli analyzes Colenkin bones in the town museum. Comparing measurements of these few specimens with other terror birds, they can estimate the critical dimensions of Colenkin itself. Although the skull was the most spectacular find, a complete leg bone also provided surprises.
Este es el hueso de la pata de Colenkin.
This is the bone that corresponds in humans to the connection between the ankle and the toes.
El tobillo hasta los dedos del pie.
The proportions of the leg bone are unexpectedly slender for such a large bird. Some other large terror bird species are thick-framed and thought to have been slow ambush predators. Kelenken with these bones is different.
Por eso, en las aves de terror, que son
In the largest and heaviest terror birds, this bone is short and stout, but in the faster birds, this bone is long and slender. That's why we think Kelenken was a fast runner.
lo cual nosotros pensamos que era un corredor.
Kelenken is among the tallest and fastest in the terror bird family. It weighs in at 400 pounds and stands 7 feet tall. It stands on slender but muscular legs, hinting at a fast running speed. From beak to tail, it's 9 feet long. But when seen from the front, it appears surprisingly narrow at 18 inches wide, perhaps less obvious to prey animals on the lookout. But Bertelli discovers that the bird's sheer size takes a back seat to the enormous strength of its bite. The bones of Kelenken's skull bear scars of massive muscles attached to the temples, a clue to the power of its gigantic jaws. These muscles control the bite force in most animals and represent one of the things even humans have in common with terror birds.
Si colocamos nuestra mano en esta zona,
If we put our hand up here and open the jaw, we can feel the contraction of the temporal muscles.
la contracción de los músculos temporales. Estos músculos, la cicatriz dejada por estos músculos en el cráneo.
The scars left by these muscles occupy a large part of the skull's roof. That gives us an idea of the tremendous bite force this bird had.
Tremenda fuerza que tenía esta ave al morder.
Another set of scars reveals powerful neck muscles. With such strength, the terror bird was fearsome in lashing out viciously with its frightening beak and its nail-like hook.
The terror bird, using its head as a pickaxe, would plunge the nail of the beak into the prey animal, and it could slice through meat, but also through certain bones.
A terror bird's head was a killing machine, a weapon propelling it to the height of power, becoming South America's unchallenged apex predator. In South America, the head of the terror bird Kelenken is driving new research into these extraordinary predators. The fossil skulls of the terror bird family are evidence of their use as weapons for swift, efficient attacks. But now, advanced technology can tell us how those skulls worked.
All right, this will be exciting.
In the United States, 2 scientists prepare to use a medical CAT scanner to probe the inner structure of terror bird skulls.
Let's get this thing set up.
Larry Whitmer is a professor of anatomy at Ohio University. He's hosting Bob Chandler, a terror bird specialist from Georgia State College and University.
All right.
What are you doing now?
Well, we're going to get it lined up here so that we can get it sort of centered and square within the X-ray beam. So we'll run the laser right down the top there. We're good.
The process takes the skull of a terror bird and turns it inside out. The entire scan lasts less than a minute, but the pictures it produces will provide clues to the nature and behavior of terror birds as they lived and hunted.
One thing we can tell by looking at the skull is that this is a relatively very strong skull. We can see that this pillar in front of the eye socket is really tall and strong. We see this bar along the cheek line right in this area is also tall and relatively thick, suggesting that the skull was built for both delivering and withstanding relatively large stresses.
A fact that the peaceful plant-eating Homolototherium may have experienced firsthand as it faced the terror bird Kelenken.
The Homolototherium was certainly one of the potential prey items for the Kelenken. It's a hoofed animal that really has no modern relatives.
Slow on its feet, the 600-pound Homolototherium outweighed Kelenken by 50%. The kill required a specific strategy.
One of its possible strategies would be to go for the base of the skull and to try and paralyze the animal.
Once the prey was down, a terror bird's beak was all about shredding flesh, a familiar behavior in birds of prey even today.
I know.
Joe Camp is a Southern California animal trainer. Using a modern-day hawk, he demonstrates how the sharp hook is a primary tool for any bird of prey, living or extinct.
It gives you a really good idea of how the beak works. Basically, you can see the hook tears into the meat. You can see her doing that, kind of stabbing it. Then her lower bill comes up and shears it, and then she tears it on off. The bill itself is almost like your incisors, with the hook of itself being what would be like our fangs or an animal's fangs.
The terror bird's gigantic head was more than a mere feeding tool, however. Paleontologists see it as its primary attack weapon. Inspiring scientists like Stephen Rowe to test the true strengths of the skull.
We're looking at a potentially horrendous predator here. This would have been a very scary bird.
How scary? Working at Australia's University of New South Wales, Stephen Rowe has loaded his computer with detailed data from a terror bird skull.
What I've done here is build a very detailed computer model of the skull of a terror bird.
Rowe has put his model through simulated movements to measure the stresses on the terror bird's skull in the attack mode during the violent mechanics of a kill.
What this allows us then to do is to digitally crash test the animal, or digitally crash test the skull. So we can run it through different hypothetical behaviors to assess just how well the skull performs.
Rowe's crash tests measure what kind of stresses are on the skull when the terror bird swings its head down, when it pulls its head back, and when it shakes its head from side to side. Stresses in the simulation are color-coded.
Blue means very little or no stress. Green, a lighter blue through greens is medium stress, and then up into red, pink and white, high stress regions.
The digital simulations offer insights into the bird's attack capabilities, as well as what might give them trouble. The analysis supports the belief that terror birds use their heads to swing down, striking pickaxe style into prey.
The animal has a prey item at the tip of its beak here, and it's moving its head down. Its neck muscles are pushing the head down into the prey. Under these conditions, the beak itself is not under a great deal of stress.
When the terror bird bites and pulls, the skull also shows a lot of blue, meaning very little stress. Pulling with the beak is classic behavior for a bird of prey.
The terror bird is well adapted to tear that prey apart with its beak by driving the beak in and pulling with that wickedly recurved tip of the beak there.
But Rowe's electronic assessment also revealed a weakness in the mighty terror bird. In attacking and feeding on prey, it would never shake its head from side to side.
Here in this third simulation, the bird is biting down into a prey animal and shaking its head from side to side. And under these conditions, the terror bird's skull lights up like a Christmas tree. It really does not handle that kind of stress well at all.
While Rowe's simulations show how the hardware of the terror bird's head was used, Whitmer and Chandler are reaching beneath the skull's surface to uncover clues to the creature's behavior.
But here, I mean, it makes this complete shield across the top.
The CAT scan goes beyond the beak, delving deeply into the terror bird's head with unexpected results.
Well, one thing that the CT scan showed was really quite a surprise, and that is, if we look on the inside here, is that within the beak was a large hollow cavity. This was completely unexpected. It was completely hollow, which raised the question, why would they have this completely hollow structure? One thing I think could be going on here is that this bill, this hollow bill, was a resonating structure. They may have actually used, like some birds do today, sort of clacking movements of their jaws that would have resonated within this large hollow space.
The clack of the terror bird may have been a familiar sound on the prehistoric savannas, but what was its purpose? A mating call? An alarm signal? The CAT scan can't answer those questions, but it can show us how well terror birds could hear such sounds.
Well, let's zoom in here on the ear and see if we can see what's going on here.
None of the terror bird's soft tissue remains, but the spaces left by organs like the brain and inner ear show what they look like in exquisite detail.
This is called the cochlea, and that's the hearing organ. What this tells us, it's very long and straight. The great length of that suggests it was potentially able to discriminate sounds well.
And it's in the inner ear that the CAT scan reveals the critical system controlling the terror bird's superb agility.
What we can see in terror birds are a series of long, delicate, thin canals. What this suggests to us, it had very sophisticated sense of balance and making the quick turning movements that a pursuit predator has to make. What we see here is the neural equipment that allowed that to take place.
A small animal scrambling to hide may have had little luck, as the terror bird would easily scoop it up and swallow it whole. A shocking example of instant gratification. If this was part of terror bird behavior, they may also have coughed up pellets of undigested fur and bone, as predator birds do today. If computer-generated images of its ear canals can tell us the terror bird was such an adept hunter, what can we learn from the same kind of pictures of its brain? Besides being larger than other animals, the terror bird brain was hardwired for eyesight. Large optic lobes, as well as expanded higher brain centers, work together to receive and process what the terror bird sees, all critical for targeting and attacking prey. There is also the surprising lack of any sizable olfactory bulb, meaning it did not make much use of smell, which strongly suggests it was a highly active predator rather than a scavenger. Some large carnivores, bears for instance, are also scavengers, relying on their sense of smell for finding dead meat. The CAT scan tells us terror birds were not members of this club.
This animal clearly was not emphasizing the sense of smell. What we see here is the brain of a predator.
What might have been going on inside its brain when the terror bird came across prey such as the glyptodont?
The glyptodont is certainly one of the most distinctive South American mammals with this solid bony armor. The glyptodont that lived at the time of the Kalenkin was about a 200-pound animal. It's completely covered with armor over its back, surrounding its tail, and on the top of its head. So you're talking about an animal that would be very, very difficult to kill simply because often this bony armor might be an inch thick.
Here is where terror bird brain power comes into play.
Now, although we sort of have this joke about bird brains being small, this is actually a relatively large brain, and these higher centers here are the cerebral cortex. And what we can see in this terror bird is that these are expanded. And what that tells us is that this animal, in fact, did have some capacity to deal with unique things and little wrinkles in its environment. This is an animal that could potentially do some problem solving.
And the thick-shelled glyptodont was definitely a problem.
I visualize the Kalinkin sort of walking around this glyptodont, trying to figure out how it's going to get to it, and basically sort of cocking one eye, checking it out. Finally, after studying the glyptodont long enough, I think the terror bird could have figured out that if it got its foot underneath the edge of the animal's shell, it could flip it over on its back and expose its soft underbelly.
South America was a cornucopia of prey for Kalinkin and its relatives. As an active predator, a 300 to 400 pound terror bird had to eat 20 to 30 pounds of food a day, and the isolated continent provided it, remaining for the terror birds a virtual Garden of Eden.
You really are talking about a smorgasbord of potential prey with very little competition that the terror birds could feed upon, some of them reaching quite large size.
But nothing is forever. Our planet is an ever-changing one, and for the terror birds, the paradise of isolation would begin to crack with the rumblings of a volcano. Until 1961, scientists thought terror birds lived only in South America. But a lump of leg bone and part of a toe raised an intriguing new possibility.
When Titanis was first found in North America, it wasn't believed. It was thought that it had to be something else.
This videotape shows scientists working underwater in Florida's Santa Fe River at the exact site where they found fragments of a creature identified as Titanis walleri, the first and still the only terror bird known in North America.
Can you imagine the thrill that it was to have this first specimen, an unknown species that was here in Florida?
This creature, from a continent isolated from the world by water, ended up nearly 7,000 miles from its origin. Its route was paved in the lava and ash from Earth's volcanoes.
Oh, this is a big volcanic ash, a lovely piece of ash. Really very
In Central Oregon, geologist Greg Ritalik shows paleontologist Jordy Duckler how volcanoes can quickly change a landscape.
Part of a big eruption. It's a rather unusual kind of volcanic eruption.
Ritalik says the deposit in Oregon was created by an ancient eruption in the Pacific Ring of Fire, a string of more than 400 volcanoes ringing the Pacific Ocean from New Zealand to Chile. Part of that ring is in Panama, where North and South America were once separated by a water gap.
The two continents were joined by volcanic activity in the Central American Isthmus in the late Miocene when the terror bird was on the march.
The connection was formed largely from lava-producing volcanoes rising from the sea, as well as the uplifting of tectonic plates. But there's more to the story. The native jungles of the new land in Central America were not the kind of environments through which terror birds would have migrated. That's where volcanic ash deposits like the one in the Pacific Northwest come in.
Mount St. Helens was an eruption of this sort, but it just created about 1 meter of ash. This one created 110 feet of ash, and at 600 degrees centigrade, it was a much bigger eruption than Mount St. Helens, and it would have created enormous stretches of open country.
The volcano that created this deposit exploded 200 miles away. The thick layer of rock it left behind can be seen in places over an area of more than 120,000 square miles.
The unfortunate creatures that are in the way of this flow, they're gone.
They're toast. Everything. There are trees, animals, all sorts of things. They're just burnt to a crisp. There's no sign of it. 600 degrees centigrade, that's more than a crematorium.
How fast are we talking about in the motion? Anything you could outrun?
Well, no, they couldn't outrun this. This is death on wheels.
Between 3 and 5 million years ago, eruptions like this in Panama resulted in what Ritalik calls instant land resurfacing. destroying jungle and briefly giving terror birds pathways to the north.
So for the short period of time when the plants come and recolonize this devastated landscape, there's a lot of open country for open country creatures like terror birds, for example. If the terror bird encountered eruption of this sort, if it survived it, it could migrate through that new country for 200 or 300 miles.
The bones of Titanus in Florida are strong evidence showing that terror birds use the Isthmus of Panama to migrate to North America. When volcanoes filled the gap between the two continents, the resulting land bridge made migration possible. The birds expanded into familiar savannas, now accessible by the new route.
I think terror birds are like many other species that if the habitat is present, they'll try to occupy as much of it as possible.
Since the original discovery in 1961, only a handful of North American terror bird fossils have been found.
Presently, in North America, there are 42 specimens of Titanus. 41 of those specimens reside here at the Florida Museum of Natural History.
Without a skull or any other large fossils, it's almost impossible for experts to piece together a complete picture of the North American terror bird. All they have to work with are scant bone fragments. Irv Quittmeyer calculated the key dimensions for Titanus by comparing the proportions of its bones to other terror bird species. For instance, he used the base of the Titanus leg fragment to figure out the whole bone's length.
When we examine this bone, we see that it's quite broad, and such a base must have supported a long shaft of bone and a tall bird. The way that this would work can be illustrated by using these lumps of clay and ruler. In a small base, this would just fall over. So it needs a large base in order to hold it in place, and with a smaller one here. So, a large base, long shaft of bone, tall bird. Smaller one with a smaller shaft, smaller bird.
Quittmeyer's numbers game involved comparing measurements from 16 different terror bird species. He even investigated the South American Seriema, the terror bird's closest living relative. The calculations provided the critical dimensions needed to build the Florida Museum's spectacular metal skeleton of Titanus. A complete view of the terror bird as a whole. Scientists concluded that Titanus was strikingly similar in form to Kelenken, the tallest of the terror bird species. But Titanus is about 20% shorter. The smaller size may have made it faster and more agile. The terror birds that came north were part of the Great American Interchange, a broad exchange of species between North and South America by way of Panama. The terror bird needed its speed for the new prey it encountered. Chasing a swift horse would have been a challenge for Titanus. The fastest running birds in today's world are ostriches. Similar in shape and size, they offer us a way to figure out how terror birds ran.
Some terror birds compare very well in terms of their limb proportions to an ostrich. And so you would be fairly confident in reconstructing terror bird locomotion as something like that of an ostrich.
Since ostriches can easily run 30 to 40 miles per hour, they're not easy to pin down for a demonstration of their technique. So, biologist Kevin Middleton has invited gymnast Henry Holloway to the University of California campus in San Bernardino to explain how creatures like ostriches or terror birds can run so fast. Holloway will show how his human legs can work just like ostrich legs with the help of some special equipment.
It's a jumping stilt. This is an aluminum frame with a carbon fiber leaf spring that's gonna give you back what you put into it.
The jumping stilts will allow Henry to run like an ostrich by mimicking the long, springy tendons in the bird's legs. But the anatomy of the bones is part of the equation as well.
This is the thigh bone, the knee, the shin, and the foot. In a bird, the foot would be much, much longer. And then when Henry stands on his toes, this is how a bird runs, on its toes. The longer foot is important because it gives greater leverage for the muscles and allows longer strides.
The apparent backward knees in a fast-running bird are really the animal's ankles. It's a dramatic illustration of how long those foot bones are and how much leverage they supply.
Let's do it.
For Henry Holloway, the high-tech jumping stilts essentially lengthen his short human feet, giving him the ability to run like a terror bird.
Go!
As he goes, each stride is 7 feet long, and he can do 23 miles per hour. Terror birds with bigger legs and bigger muscles had 10-foot strides and could probably do 40, just as ostriches can today. During a high-speed chase, Titanus had to run to the side of a primitive horse to avoid kicks from its hind legs. The terror bird struck effectively from this offset position.
With that pickaxe, drive the nail into the back of the neck, make a severe wound there, and then allow the animal to bleed to death before they came in to finally dispatch the animal.
But life would not be easy in the new continent for Titanus. It was about to make first contact with the local predators in the north. These were new competitors without fear, but then they had never faced the power of a terror bird. Around 5 million years ago, in what is now the southeastern United States, a mysterious newcomer from South America feeds on a primitive horse. The terror bird was the top predator in its ancestral home. But here in North America, it has competition from creatures it never encountered before.
At the same time that Titanus was here in North America, there was a small wolf-like animal called the Edwards wolf. Not as large as gray wolves today, but larger than a coyote.
Hunting in a pack, the wolves are there to steal the terror bird's prey. But this is a challenger they've never seen. They depend on instinct and spread out.
This is a battle for attention. Who can divert the attention of the other combatant and in which direction and for how long? If you're distracted long enough to have to fight one wolf, there's not really a chance that you can expend your energy keeping the other wolves at bay.
Modern wolves are known for wearing down their targets, and their prehistoric cousins were likely the same.
I think probably the defining moment is when the Titanus feels like its life is endangered.
Once the terror bird gets the idea that it's, in a sense, outnumbered at a strategic level, it's probably not going to expend its energy over that carcass. It's probably going to divert its energy somewhere else.
The crisis is critical for Titanus. As the wolves close in, its attention turns to escape. Neither side can sustain the tense standoff, and one swift exchange will prove decisive. Making a willing sacrifice, the wolves prevail. Lesson learned, the terror bird withdraws. Its native intelligence driving it to change its hunting strategy.
So I could certainly see a terror bird after its first encounter with a pack of wolves possibly realizing that it's not worth the fight, it's going to lose in the long run, and eventually start developing avoidance behavior that if it kills something, the wolves come along, it's probably going to give it up rather than risking itself becoming a meal as well.
Predators also posed a danger to terror bird eggs. Scientists believe they were similar to the eggs of ostriches, which are eaten by modern predators. In today's world, predators may be able to scare ostriches away from their eggs. Prehistoric predators, however, may have had to wait for a terror bird nest to go unguarded. If terror bird eggs were like ostrich eggs, how strong were they? To test the notion, we placed a wooden plank on a single ostrich egg and added iron weights 25 pounds at a time. The plank concentrates all the weight at one point on the shell. But even with this stress, the egg supported 175 pounds before finally breaking under the load. But the strength is illusory. An egg dropped from 2 feet cracks easily. One egg rolled against the other does the same. An Edwards wolf may have needed no more than a little persistence to crack a terror bird egg to get to the tasty meal inside. But Titanus also faced other predators in North America. Among the most dangerous was Smilodon gracilis, a smaller ancestor to the giant saber-toothed cats that would arise within the next epoch. A modern-day encounter between cheetahs and ostriches may mirror the way ancient cats avoided adult terror birds. Their chicks, however, were another story.
You can certainly visualize a female terror bird with her chicks out for a stroll. One of the chicks wanders a little too far away from the group. Saber-toothed cat jumps out, grabs it, has terror bird chicken dinner.
Not so fast. Mother terror bird springs into action.
If the saber-toothed cat can't escape, it's going to go into offensive mode itself, use its claws to go for the breast of the animal.
But here, the terror bird has superior weaponry. It strikes with its giant head again and again. The cat is killed. But too late to save the unlucky chick, lying nearby with a broken neck. Life in North America must have been more difficult for the terror birds than it was in the South. Here, it faced predators like the cats and wolves, destined to evolve into the giant megabeasts of the future. These new competitors threaten the terror bird's very existence. Titanus as a species was in mortal danger. The reign of the terror birds lasted nearly 60 million years. They were top predators in South America and adventurous immigrants to the north. But their extinction is a complex puzzle that scientists are still trying to unravel.
Trying to come up with a good, simple explanation for the extinction of any group of animals is very difficult.
One factor may be the Great American Interchange, the mixing of species migrating between North and South America, making life for terror birds more difficult.
One of the things we can look at is lack of competition with other predators, and the fact that once you start getting North American predators, dogs, cats, things like that, there's increased competition for food supply.
2 million years ago, terror birds in North and South America may have been hard-pressed to find a meal when saber-toothed cats shared their territory. The pressure from predators and competitors may be two factors in the terror bird's extinction, but there's also a larger picture.
It's my opinion that the terror birds were not outcompeted by mammalian predators, but in fact it was a global change in climate.
2 million years ago, the Earth entered its series of ice ages. The glaciers in the north tied up ocean water as ice. The sea levels dropped, which lowered the groundwater table in places like Florida, where Titanus lived. The landscape dried out.
It's going to have a lot drier vegetation. This affects what's available for its prey to eat. So you're going to have a change in the numbers and the variety of animals that Titanus might have been feeding upon. So it's sort of a domino effect with the climatic change leading up to eventually the demise of Titanus.
In South America, the Andes continued the upward push they have been making for millions of years. blocking more and more rainfall as time passed, the savannas to their east changed into drier steppes, further robbing terror birds of habitat. Environment, predation, competition. Each is a suspect in the mystery of the terror birds and why their long success finally came to an end.
Is it one? Is it a combination of all three? It's too early to tell at this time, but that's part of the challenge of what we're doing in this science, is as we build upon our knowledge of these animals and understand them a little bit better, we can eventually get to that ultimate question of why aren't they around today?
The epilogue of the terror bird story is still unfolding in the fossil digs of Florida. While the big birds were known to have roamed the earth millions of years ago, it was once considered possible that Titanus, the last of the terror birds, may have lived as recently as 10,000 years ago. This means they might have had contact with humans.
Titanus, we have not seen a single fragment. It's probably just not the right environment for Titanus.
It's the right time, the right age, but it's not it may not be the right environment.
Scientists Richard Halbert and Bruce McFadden direct a dig in a limestone sinkhole where sediments hold fossils of the Great American Interchange. The timeline riddle for Titanus was important to solve. Humans on the same turf as terror birds could have hunted them out of existence.
If Titanus lived until about 10,000 years ago, one possible explanation for why Titanus, the terror bird, might have become extinct was human influences, because it's pretty clear that by that time, humans were spreading through North America.
The problem was this. On dry land, fossils are found in sedimentary layers. The position of the layer usually corresponds to the date of the fossil. But the Titanus fossils were found underwater, where the Santa Fe River had moved them around.
Where are these fossils from? Because then they're found as single individual fossils out in the middle of the stream rather than in-place sediments in the sinkhole.
Divers found the Titanus fragments mixed up with bones from animals known to have lived 10,000 years ago. So how old could they really be? Bruce McFadden solved the mystery with the chemical signatures of the minerals in the fossils. He compared Titanus bones to specimens known to be very recent and others known to be 2 million years old.
When bones become fossils, they absorb minerals from the local groundwaters, and those minerals are unique for every period of time. So fossils that are formed at different times have different chemical signals.
McFadden ground tiny amounts of fossilized bone from the Titanus pieces and prepared them for analysis by a mass spectrometer. The result gave him a clear profile of the chemical elements in the terror bird bones. Conclusive proof that it lived long before ancient man reached North America.
And we have two basic patterns. We have a pattern for the very young bones that are about 15,000 years old. And then we have another pattern of bone, which actually is up here, that represents animals that are 2 million years old. And the Titanus specimens plot exactly over the concentrations of elements of the 2 million year old fossils.
But amazingly, the story didn't end there. The terror bird had more to tell us about its survival in the north. McFadden also found that a Titanus fossil from Texas was not 2, but 5 million years old. It means the terror bird lasted in North America for at least 3 million years, a long run for any species. It's a remarkable statement of adaptation and a fitting last act for this spectacular family of predators. Despite a wide range of new competitors, Titanus was the proud successor to the terror bird legacy. In its final home in North America, it didn't just survive, it thrived.